Okay, so how many of you can graph these two lines right now? Not the shading, but just graph the lines. Yeah, no problem. So what method do you use to graph it? Yeah. Y equals mx plus b?
Yeah.
Okay, so that's exactly what I would do here. The first thing that you do is you make it an equals to. So the first thing that you need to do is change it to an equals to in order to do this. Then I isolate my y, so I get minus x plus 5. So what's my y-intercept coordinate? Where's my starting point? 0 and 5, right? And then what's my map tell me to do?
Down one to the right one, or up one to the left one.
Okay. So the way I've written it here, it would be what? Down 1, and then right 1, correct? So my starting coordinates 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. So I go to here,
No.
down 1, right 1 to here, and I gotta go over here. Now, before I graph it, solid line, dash line, which is it?
Solid.
Solid because equals to, right? Okay, here's the second method, and this is the reason I want to show you this today, is this is the method I suggest you use if you're not going up by ones on your axes. Okay? If you're not going up by ones and you're going up by 5s or 10s or 4s or whatever it is, don't use this method. Okay? If you have large numbers, don't use this method. Because you can't really find that second coordinate properly. So the method I would use is my intercept method. Put 0 in for x, solve for y. Put 0 in for y and solve for x. In this case, what's the value for both of them? I put 0 in for x, y is equal to 5. I put 0 in for y, what is x equal to? 5. So I have my two coordinates. I draw my line through those two coordinates. It's a solid line because it's equals to. This is the method you want to use if the numbers are large. Okay? If you've got a big graph and you've got to go up to like 50 or 100, that's the method you want to use. Don't use the slope-intercept method. Only use slope-intercept if you're going up by ones. Fair enough?
Yeah.
Okay. So now the shading part. How do I determine whether I shade up here or down here?
You pick a solution point and then figure out if it is with the solution or if it's not.
Okay. So you could pick any coordinate that you want. I pick 0 and 0 because the math is easy. So I put 0 in here and 0 in here. Is 0 less than or equal to 5?
Yeah. No. Yeah.
0 is? Yeah. So then that's a part of my solution, isn't it? So I'm going to shade down here. Right over that. Now if you're not sure, you go ahead again and you pick another coordinate. Maybe even pick one up here. Pick 5 and 5, let's say. 5 plus 5 is 10. Is 10 less than or equal to 5? No, then it shouldn't be in my shaded region, should it? The whole part about shading is it gives you multiple solutions that are not necessarily on the line. When you graph it as x plus y equals 5, that says that every coordinate on this line will give you a value in which you add them together, it would equal 5. But when you do a solution where you've got a shaded region, it means that when I add them together, they're always going to be less than or equal to 5. The equals part occurs where?
In the equation.
On the line.
On the line. The equals part is on the line. The less than part is everything down here.
So, in what case would you have to stipple?
I'll get to that. I'll get to that in 1 second. Okay. I'll graph the next line and then we'll talk about that. Okay.
Okay.
All right. So now this guy again is going up by ones. So I would let this be X plus 3y is equal to 0. Y is equal to negative 1 over 3x. Okay, so what's my starting coordinate? 0, 0, 0, right? And where does my map tell me to go?
Down 1 and 3.
Down 1 and 3 to the right, so somewhere over here, right? Correct? Okay, solid or dashed? Dash. I don't know if I drew that as a dash this morning, Jacob. Did I? Okay. So there's my dash line right there. I need to, go ahead,
Why dash?
because there's no equals to here.
Oh, okay. I was
Okay? So what's the next step? Shade. So find a coordinate, right? Let's use 0 and 2. It's up here, okay? 0 plus 6. Is that greater than 0? 6 greater than 0? Yeah, so I got a shade in here, don't I? Now remember, I don't shade over top because I've already established that it can't be any higher than this. So where's my shaded region?
Why don't you shade over top?
Because it won't satisfy this equation. I could, but the actual solution has to be in here. So yeah, you could shade.
Just then that you can make that darker.
Yes. Yes, then I have to somehow indicate that this is the region of all my solutions. Okay, so far so good? All right, now, one of the other things that you're going to go through as we do this is once you get your shaded region, you're going to have critical points. Critical points are connecting points, so where that's equal here. Maybe your intercept up here. Maybe an intercept down here. Those are critical points. We're going to eventually get there. In the next 2 lessons, we get to critical points. They become the coordinates that you use for your objectives after. But that's a little ways down the line. But I just want you to understand that where there's intersections with either the axes or with the lines themselves, we call those critical points. Okay? Now, to the stippled part. The only time I stipple is if I have this given to me. Because if it's x is an element of integers or x is an element of whole numbers, there are no decimals as part of your solution. Do you understand? So then that's where I have to actually put in dots in here. Okay? Now if it's integers, they can be over here, right? Because integers can have negative numbers. But if it was just whole numbers, they would only be in this quadrant right here. Agreed? And it would stop. It would be just in here. So my line would be stippled. It's like that. So if it was whole numbers, it would just be this area right here. None of this down here counts. It would just be in here. And that's only if I write that. Does that make sense?
Yeah, do you stipple on the line too?
Yes.
Only if it's solid. If it's dashed, it's not included, right? So
Right.
you don't do it on those ones.
Yeah, very good point. Okay, so the solid line here, got it? This line doesn't get it. Is everybody okay with that? Yeah? All questions answered now? All right, so we have 6.2 and 6.3, right? Should have to the end of 6.3. Okay. Any other questions? Anything you want to see in your books before I shut this down? Okay. Ms. Ludwig's going to do an activity with